We were just giving you a moment to get up the stairs, over and down the stairs before we started, so we haven't kicked off yet. We'll kick off in a minute. Do it later. Okay, good morning, everyone. Welcome to this morning's session. We're going to have a fun-filled 3 hours about my 3 favourite topics. For those who don't know me, I am Kate Ebrill from CSIRO. I sit on the board of HL7 Australia with our Sparked program, which is a FHIR accelerator. We're bringing together openEHR, FHIR and SNOMED. So as I said, these are my 3 favourite topics to talk about. We have some amazing speakers lined up for this morning, but we're a really nice sized group. So we really want to keep this interactive. This is a really chance to learn, to discuss, to share how we're actually implementing these standards and importantly, using these standards to support the implementation of SNOMED. So please feel free to ask questions. The plan for this morning is we'll have 3 quick kind of intros to FHIR, introduction to openEHR and introduction to FHIR Terminology Services. But then we want to leave a 30-minute block for actually a good chance to have question and answer and discussion with them. And as I said, this is interactive, so we really are keen to have your input as we go. Then after the break, Michael Lawley will come back and bring it all together. So everything that we've done with the 101 in the morning, no pressure, Michael, no pressure at all, but he's going to bring it all together around information models and terminology bindings. And then we have some case studies. So thank you to the countries and industry members who've put up their hand to provide us some case studies around how they're doing it in their regions. But if any of you in the room also really want to share, there's time in the agenda if you're also keen to share what you're doing in your implementations and ask questions. As I said, we want to keep this as interactive as we can. And I think we will, so I forgot the objectives. The objectives of today are really to understand those basic concepts around FHIR, openEHR, and how FHIR Terminology Services actually supports the use of SNOMED within these implementations. We want to understand key considerations when implementing SNOMED in openEHR and FHIR information models and explore case studies and use cases within member countries and within implementations. Now trying to find Alt-Tab, Carly. Haven't had my coffee. Yeah, so let's get started with a quick Menti. And so you can use the QR code or you can join at menti.com and use 75325100. I know that there are a number of participants online, so we'd also like to hear from you where you're from. Not surprising to see Belgium. So great, and thank you, Belgium, for hosting us in your beautiful country. We have had a fabulous week so far and looking forward to another few great days. It's great to see that we've got people from all across Europe. We've got Australia. I wonder if there are any Australians online who aren't just those that are in the room. Malaysia's joining us, US, New Zealand. Is that you, Alistair? The Netherlands, Sri Lanka. It's a fantastic mix of countries from across the globe. And one of the true values of open standards and standards development is the ability to bring everyone together from across the globe. Jump to the next question. What kind of role do you most identify with? We never get this right. We can never cover all the roles in the room, no matter how hard we try. think this is one of the also valuable things around standards development, where we bring clinicians and consumers, health informaticians, software developers, government and policy all together in the room. Give that another moment. How well do you know FHIR, openEHR and SNOMED? Are you a beginner or are you expert? I'm looking at the table of experts right in front of me. Not surprising at a SNOMED conference that we're looking at heading towards a more expert level of SNOMED here. But good to see that we've pitched this right with some that are relatively maybe a little bit newer to openEHR and FHIR. And that's what we really wanted to do, was make for all of those SNOMED experts in the room, how do we bring the openEHR and FHIR and bring those standards together and have this discussion around how they're implemented together. So this is fantastic. See, it's a good thing we don't have SNOMED 101. At your country level, do you have a national program that's implementing any of these? FHIR, openEHR or SNOMED? Or none of them?
I think I'm done. Just if I'm gonna have it dessert.
You want that on now?
Okay, so a few that are implementing openEHR at the national level, quite a large number around FHIR, and great to see the number of national programs around SNOMED CT. And for those countries that said none, is there a plan for doing that? Is there a plan for, does anyone want to put their hand up or say, yes, there's a plan, but we just don't have it right now? Oh, and then are they? Now, I'm just going to put this up here around so you can have this open on your Menti through the session. So we're going to come back to this Q&A slide, but if you've got a burning question as you go through, you can enter that question into the Menti so that when we come back to that panel, it will be sitting there waiting for us. So just a chance, you don't have to write it down, you can put it into the Menti right now. So first up, Michael. Invite up Michael Lawley to start with the intro to FHIR 101. Thanks, Michael.
Hey, first a little bit of logistics. Oh, you have to stop sharing. Oh, wait.
I've stopped.
Okay, looks like we're all set. Hey, welcome everyone. This is a very awkward shape of a room to address because I feel like I'm talking to you, but now I've got everyone over there, so maybe I can do that. So I'm going to give a brief introduction to FHIR. I'm not going to get down into the technical weeds. There'll be a little bit of technical stuff. The idea is to give you a sense of the pieces, enough to make sense of the rest of the morning, and hopefully to broaden horizons, and get a sense of where SNOMED connects into this piece. And then we've got other parts of the story that our other presenters are going to cover. So HL7 FHIR, you've probably heard this before. I'll say it again. FHIR, Fast Health Interoperability Resources. That's the kind of backronym, I think. The fast really intention here is fast to get going. So conceptually, for a software engineer, and this is really a spec that was designed for developers, for implementers. The idea was that you didn't have to learn a whole new stack of stuff to get going. You still need to have an understanding of healthcare, how healthcare is done, how it's delivered, your national environment and all of those sorts of things. You're not going to get that in a fast way. But the actual specifications, the technical end of things, is intended to be familiar. It's an interoperability standard, right? So it's in a context of existing systems. It's for sharing and exchanging clinical information. It doesn't make assumptions about how information is stored. And the focus on the now, we're dealing with where we are now, right? And moving forward. There's different parts to FHIR. There's the content model, the resources, which I'll emphasize here. There's exchange. So along with the resources, there are APIs and ways of interacting with those things. And then the most important part, which I've put here in bold, is community. So you don't get interoperability without exchanging information and understanding. You need community for that. But I'm not going to emphasize the community here. But just one takeaway is that you're here, so you're now part of the community. Okay. So scope, it extends into clinical knowledge, it extends into decision support, quality measures, and so there's the core of FHIR, and then as time has gone on, it's the scope has broadened out in some places quite considerably. There's a lot of reference materials, online training. You can get a much better intro to FHIR if you go to YouTube and search for FHIR Dev Days and watch some videos there. Lots about FHIR terminology there as well. So there's lots of rich sources of information, and chat.fhir.org is where the community comes together online. So it's very welcoming. Join, ask questions, and have fun. So, fast interoperability resources, healthcare resources. What are resources? So they have a set of features, and whoops. They have a URL, so it's a modern standard built in the context of the web. So things have URLs. There's common metadata, so there's things that are common across the different resources. There's a human readable, or the place for a human readable summary of what the resource means. Common data elements, an extensibility framework that's used quite heavily for everyday use. It's not like exceptional use, it's a core part of the framework. And generally the resources are exchanged in an XML or a JSON format. There are other formats, but those are the two primary ones that are in use. So what does the resource look like? Well, here's a page from the spec. This is defining the patient resource. I apologize if it's a little bit small. You don't need to read the details. The intent here is just to get you familiar with the look and feel of what these parts of the spec look like, and how to navigate it. FHIR comes with a maturity model. So when it started, everything was maturity level 0. And as time's gone on, we've had more experience with using it, deploying it, implementing it. and settling down on the details. The maturity model of these resources has increased, and there's actually a whole formal maturity model built around whether things are implemented, how many systems have implemented it, whether it's been tested, and so forth. And that's that's the thing that drives the maturity model. You can get a sense of how solid things are by this. Things that are normative, that means they won't change without good reason, or they won't be changed in a breaking way without really good reason and without extensive community consultation. So patient had a lot of work, it's normative. We have data types, so all the fields in a resource have set data type. There's a standard set of data types that you might be familiar with, like booleans and strings and integers and so forth. Then there are some more structured or more complex data types, things like human name. And then there's things that are actually really interesting to an audience who's into terminology, the codable concept and coding and code. So you'll see some examples of those here. So administrative gender is a code. Marital status is a codable concept. And I don't see any codings there, but and they allow you to express things with different degrees of detail. When you have terminology based fields like code and codable concept, you also have the notion of a binding. And so code type says code goes here, the binding says what are the valid codes to go here. So in this case for gender, there are 4 valid codes, male, female, other and unknown, and that's it. So this is a required binding. You can't have values other than that. Down here we have an extensible binding, and I'll talk in much more detail about the different levels of binding. Extensible binding says it must be a value from this value set. So the value set defines a set of codes, but it might be a different value. So here's a starter set, but with good reason, i.e. you need to express something that's not expressible in the existing set of codes, you can choose a different code. Then we have cardinalities, so they say how many, whether you've got repetition, whether something's mandatory or not. So what does a resource then look like? We've seen the sort of the high level structure. The actual resource in XML format. I talked about the different parts before, about the URL, the identity of a resource, the human readable bit, extensions, and the actual body of the resource. And so you can see these here color coded and separated out. So this ID here gives us the identity of the resource in a FHIR server. So it's not tied to the resource itself, it's an implementation detail. The actual sort of logical identifiers for things like a patient come from the identifier elements down here. So this is where you might have an MRN or a national identifier, so forth. And then here's an example of an extension. So this is recording, I believe, that this patient is somehow associated with some kind of clinical trial, which is a renal clinical trial. So it's an extra bit of information that can be put into the resource, ignored by systems that don't know what it means, but obviously understandable by systems that do know what it means. And generally this URL here will be it's an indicator to those systems about what the meaning is, and a pointer to where to find the technical details of what that meaning is. So we have these resources, they come together. So they don't live in isolation. They are a set of resources, and they all fit together in a web. So just like in the World Wide Web, the internet, you have web pages that are all linked together. Here we have resources that can reference other resources. So an encounter may reference a patient, and it may reference a procedure that was performed, and so forth. So these individual resources, separate pieces of data live in a system, can be exchanged, but they can reference each other. And so you can build up this web of data about the patient and about healthcare delivery. How might that be manifest? Well, there's the International Patient Summary is an application, or has an application in terms of FHIR. So it's a FHIR representation of the International Patient Summary, which consists of a number of resources. So there's the summary, the resource that represents the actual summary itself, and then the set of resources that contains or references. And that will be the patient resource, the author, the attester, the custodian. So the information about who made this summary, the set of problems that the patient has, their allergies and intolerances, if any, medications, if any. Then there's then optional information that may go into the patient summary. And these are all different resource types. They all get sort of pulled together into this form, and then that can be exchanged. And so that way you can build up a picture or a statement about a patient from these separate pieces. And so all these things link together. I spent a lot of time talking about the resources. They're the fundamental representations of data, but of course you have to be able to interact with them. So there's a set of standard ways of interacting with these things, creating them in a FHIR server, reading them, so pulling them back, updating them, so a new version of the resource, deleting them. Delete may not actually remove it from the system, but leave a history, so it's marked as deleted, but you've got a history in there. Search, so you can find matching resources. So given a patient, find all the observations over the last 24 hours, that kind of thing. Looking back at history, so you can see how things have changed. Transactions, sometimes you need to update multiple things at once. So transactions can be used for that. And then there are a set of operations, and Peter will talk about some interesting terminology operations later on. These are where you can trigger off specific behaviors. So beyond just getting and storing data. And if you want to see all the technical details, there's a link there. But FHIR is actually more than just the resources, just the interactions. It's actually a whole ecosystem of things. There's a subscription model defined by FHIR, so that you can subscribe to changes or updates and other semantic events that might go on in a system. Bulk FHIR for exchanging large chunks of data rather than small individual resources. Probably the most important or exciting part of the FHIR ecosystem is the Smart App Launch specification. This enables an ecosystem of applications. So we get beyond just storing data, and we get to the ability to build purpose-specific applications that can be launched from an EMR, targeted at a focused topic. And the Smart App Launch deals with things like authorization and context. clinical decision support as well, and analytics and the emerging SQL on FHIR specification bridges from the sort of nested structured world of FHIR resources into the sort of flat relational world of tables, and then allows you to use all the standard tooling that you might use for doing reports and large-scale analytics. Smart Launch is built on top of OAuth 2 as the authorization mechanism. So again, building from web foundations and common foundations, not reinventing things. There's notions of launching an app. So, and when you launch an app, I guess the context here or the analogy here might be you're on your laptop, you launch an application, it launches, and you're sitting there and it's blank. Or you double click on a document and the appropriate app launches and your document is there and open and ready to use. So this launch is similar when you launch from an EMR. If you've got a patient in front of you in the EMR and you launch the app, then the context of that patient is made available, subject to authorization and permissions, made available in the app immediately. This allows things like forms to pre-populate or your app to have immediate access to the FHIR API to pull back data about that patient. It can know who the user is, so you can have the app responsive to the role that the user is playing at the time. And this has enabled, this standard has enabled an ecosystem of purpose-specific apps to grow up. Some of them, and you'll find them, there's a app gallery, as you can follow from the spec here. And some of these are demo apps, other ones are really quite rich and sophisticated, so they're not sort of single purpose things, and others are quite focused. So things like CVD risk calculations and so forth. And I think that's where I'll leave it and hand over to Peter. Or Heather.
Sharing.
Good morning, everybody. It's quite weird for me to be here. This is my first SNOMED meeting ever. So I am one of the new kids on the block, if you like, from openEHR, except we're not the new kid on the block. So I'm Heather Leslie. I'm an ex or recovering GP from Australia. Thank you. And I've been working with openEHR since 2004. So the specifications were first invented probably 25 years ago, but it's been around for quite a long time. It's suddenly getting some massive momentum at the moment. It's very exciting to see. And this is what I wanted to talk to you a little bit about today. Clearly, not a lot of people in the room know it very much, but we'd like to explain the basics of it. So openEHR, Open Electronic Health Record, openEHR, we answer to all of these kinds of things. It's the basis for ISO 13606 Part 2, certainly the archetype related information, and that's currently going through its third revision at the moment. So again, this is a specification that's been around for a long time. It's just had a long, slow burn, and it's been mainly Europe where it's had most of its momentum. So coming from Australia, it's been interesting. I get to travel a little bit. And basically what we're known for really is that we publish two things. It's the technical specifications, so it's an architecture for an electronic health record system, or a platform, it's open. And what I work with and what I'm going to talk about mostly today are the clinical specifications, where we define clinical content. Mainly, we're going to be talking about archetypes and templates. All of this is free, publicly available under Apache or CC BY licenses. So, okay, let's change format a little bit. This is going to be interesting to see. At the moment, we've got a fledgling partnership agreement with SNOMED, so that's part of the reason that I'm here, is to start to talk about how the organisations will be working together. In the last 18 months, we have become a full member of the Joint Initiative Council. We've become a full liaison with SEN 251. We've got a collaboration agreement with HL7. And in June this year in Amsterdam, we had a meeting called Converge or Collide, in which case we decided to converge, and we've got 4 joint FHIR and openEHR working groups working on various aspects of how FHIR and openEHR modelling will be able to work together, and the technical side as well. Members are increasing at a rapid rate at the moment. We've got a number of new countries who've become members of openEHR, organisations, industry members, and we're developing a large number of national affiliates. So this is growing at a great rate, and it's very exciting to see. Yeah, my formatting's actually gone, but there you go. We've got the information. So it's a data-driven shared health record. We're aiming to be able to create health records that are agnostic of any clinical system or any vendor, so that we can start to create health records that will last for the life of the individual. So looking at 100 years plus, when I'm building an archetype, I'm imagining that this archetype will be used for a long, long time. It's person-centric, and specifically it's about the health record being the data, and that data is separated from any specific clinical system. We're standardising our clinical content. It is clinically led, right? It is the best way that we've got for actually getting clinicians engaged in digital health at a standardised level, and we're getting the clinicians and other domain experts to validate these models as being fit for use and safe for inclusion in health records. So we're knowledge enabled, we're getting the little data right, and that becomes a foundation for all sorts of things, making us absolutely fit and ready for being AI enabled. And it's the only way with that foundation of standardized data that we can really scale AI. So this is really a fantastic foundation for as we move into this AI generation. The clinical modelling community, we should have tested this, Kate. Sorry, all the formatting's gone, but the information. 4,100 plus registered users in our clinical modelling community that I've been leading. We've got 1,600 plus reviewers. So these are people who put their hand up and say, I want to actually look at this content and make sure that this is fit for use and safe to be used in our systems. They're from 121 countries at the moment, and we have volunteer translations in 35 languages. We've got 674 archetypes, of which 30% are published, so they've gone through a peer review process. That's about 8,000 data elements. We've got 40,000 community hours that have been put in at least, and what's just going off the screen is that we think that's been worth at least 3.2 million euros worth of effort that's available for free for other people to start to use. So I've got a jigsaw image as well, Michael. If you look under the hood of any system that's been proprietary, been built from scratch, it's a bit of a mess. The jigsaw pieces are just sort of dumped on the table, if you like. There's no particular system or rhythm or rhyme to it. They're inconsistent, they're proprietary, fragmented and opaque. Often you can't even see what's under the hood. But what we're trying to do with openEHR is to create the perfect jigsaw. Each of these models fit together so that they don't overlap and so that there are no gaps. It's strategically done, it's coordinated, it's open and it's transparent. So when we start to look at how we do this, how do we actually deconstruct clinical knowledge in a systematic way, there's a number of approaches that we're using. So that first one is a design layer, and I'm going to show you that. The second one, we've got an ontology that sits behind it, and the third one, that there are patterns that are evolving. So how do we go about eating that elephant? If you think of this Lego city as all of the clinical data that might be in an electronic health record, so all of those building blocks, all of those structures are the content. Obviously underneath you've got the sewerage systems, you've got fire, you've got electricity, all of those things that will underpin the technical side of an electronic health record, but we're going to investigate the Lego itself. So if we could deconstruct it, what we can do is we take that city and we can recognise cranes, we can recognise buildings, we can recognise vehicles. These entities in themselves are structures that we know that we can use in systems. And if we deconstruct it further, there are building blocks, different colours, different sizes, and underneath that we've got the actual little nubbins, the size of each of the blocks. They're designed specifically to work together so that you can put them together and they won't fall apart. You can put them together, but you can pull them apart when you need to. So this is what is representing the technical rules, if you like, of openEHR. These are the things that are mutable, that are in the technical specifications that I as a clinician can't change. Data types, how the patient's recognised, who the participants are, those kinds of things. These are done in the same way for every single model. But then what we as clinicians can do is we create the archetypes, that second layer, the building block of all those building blocks together, we design those. This is our domain. It's not just clinicians, but it's all kinds of domain experts can describe and define the data that they need to use. And then we can combine them together into structures. So like the crane, like the helicopter, we can build them together into documents, into forms, into messages, whatever we might need to do to represent that data. So the Lego blocks are what we govern like hell, basically, all right? They've got a very tight governance process. The templates, the equivalent of the helicopter, this is where we allow clinical expression based on the very tight specifications from the archetypes. The ontology that sits behind it comes from some work that Sam Hurd and Tom Beale did. This was based on a paper that was from MedInfo in 2007. And I've adapted this now because this ontology gives us insight into the types of data that we have in our electronic health records. So there's things in the past, things in the future, things that are in process, and what we've got are these four classes: the observations, the evaluations, the instructions, and the action archetypes. And this is what underpins it. It's actually our secret sauce. The longer I'm involved in openEHR, the more I recognise the power of this in actually helping us to deconstruct that health record and decide what types of data that we've got that we need to be using. The other thing that's evident and becoming more so in recent years are the patterns. All right, so there's a number of patterns we built from first principles. As clinicians, we know what information that we want, and we've got other clinicians to collaborate to actually decide on how things like problem diagnosis, symptoms, the fractal patterns that we actually get with physical examination, to be able to stand in the doorway of a room, to be able to step next to the patient, to examine more, to look at a limb, to look at a wound on a limb, to look within the wound on the limb, to be able to describe this from a physical exam point of view. And all of these kinds of patterns are becoming more and more evident. And every time we build a new pattern, and it's a good one, we use as the basis for the next one. And so the whole ecosystem of data groups and data elements are actually working really well. Now, this is an archetype. So describing what an archetype is, it's a building block. As we've seen before, the Lego building block, it's a computable specification for a single concept. So things like blood pressure, medication orders, symptoms, diagnoses, family history, they're all examples. They're maximal, all right? The notion of it being inclusive of everything. So we've had quite a bit of pushback that people don't like the idea of maximal because it feels like it's actually, you've got to go too far. But in fact, the idea is we're working towards maximal, we're being inclusive of every single data element. So for example, blood pressure has about 40 data elements in it. Not that everyone wants to use it all the time, they only want 2 or 3. But we're inclusive of all the things that might be related to that. And therefore, if we share our blood pressure, no matter what level of detail, we can start to share the same things. It's designed once, reused multiple times, and we govern it very strongly. So this, again, is another critical tool for us. It's called our Clinical Knowledge Manager. You've got the URL down in that bottom corner. This is an online tool that is a library of our archetypes and some of the templates that we've got available. This is something that you can go to, freely download all of the archetypes. It is a portal where all our registered users come together to be able to actually get involved in the reviews. So this is our collaborative portal, and it's a place where we manage all of the governance. It's really the hub of the modelling community. It's our source of truth. It's our reference point. So we get very much collaborative archetype design, collaborative validation. Lots of people are actually contributing, and we take on board all of the opinions. And what we do then is we also then put it through review processes. So the reviews are where people are able to come in, make comments, and if we get consensus, we publish the content as final, which means it's fit for use, then change requests and so on. Governance processes will underpin it. In the blood pressure one that was published over 10 years ago, we had 61 experts from 13 countries, and it's been translated into 15 languages. So this is what it looks like. It's one of the ways we represent it. This is a standard view of, in fact, the tobacco smoking archetype. So you can see data elements, descriptions, some comments, bindings, things like that are in it. We can also represent it like a mind map. So we use mind maps a lot because it's a way, we've actively gone through a process of trying to de-technify these models, make it approachable for clinicians and non-technical people to participate. This is actually the source of truth that sits underneath it. The other two views that we've just seen are just renderings, but this is the archetype definition language, which is part of the ISO 13606. And then this is part of the review process. So you can see on the right-hand side, there are some people who've put comments in about particular data elements, and then you've got editorial feedback. And this is the way we give feedback to people. Sometimes it's teaching, sometimes it's accepting what they want to say, sometimes it's something that we would reject as well, and we would explain why this is not appropriate, this suggestion. But this is the consensus view in process, and this is transparent. So everyone can go back and see how we made these decisions collectively. So if the archetype is that building block, the template is meant to be the heading on this right-hand side with helicopter. This is representing data sets. So we've got multiple archetypes. It can be 1 to as many as you like. We sometimes have up to 70 archetypes within a particular data set, say for an antenatal consultation. So it's a computable specification, but it is for a particular purpose, a particular location, a particular patient, a particular reason. And this is where we get the flexibility that we're able to create clinical diversity, but based on the really solid and governed archetypes. So if you think about the building blocks at the bottom, the Lego blocks, we can create a helicopter or we can create a chicken with a rotor on its head. This is the way the archetypes can be reconfigured for different purposes. Just a cute little indication of what we can do. Now, if we've got the archetypes in the centre, the symptom, the weight, the blood pressure, etc., we can use them to create a diabetic checkup. Similarly, we can reuse the same ones for an antenatal visit, slightly different focus, but the same archetypes underpinning it. And this, in fact, is a representation of one of the tools we use for building templates. All right, so this one is a rendering of IPS, and this is showing you at the moment that we've got the IPS at the top there, so this is the name of the actual document. We've got a couple of headings here, we've got a few archetypes, and we've got some data elements, and this particular one is associated with the value set on the right-hand side. You can also see that that's the slider. So this is a large template, right? We're just seeing a couple of archetypes right at the top of it. This goes on for about 50 or 60 different archetypes. So this is the way that we work with our openEHR. You really can't see the top. This is the heading. This is our openEHR ecosystem. So we've got the clinical models. So these are our archetypes and templates. We've got terminologies. Now, we are agnostic to any terminology. We can use any terminology, but we're most frequently referencing SNOMED. And what we can do is we create these templates. And so these are our data sets. And then what we can do from there is also create a whole lot of associated artifacts. So we can create guidelines, decision support rules, workflow processes, queries based on both the archetypes and the terminology together. So we're starting to create an ecosystem of consistent data for all sorts of related artifacts, not just the archetypes and templates per se. And then what we can do is we can generate documents, forms, messages, etc. But not only can we generate these things, they're also potentially consistent with each other. So there's a lot of consistency in the whole ecosystem. And so what we're doing is changing where we've come from with traditional standards, where the voting and the balloting has been on the end results. And we're focusing back on the clinical models and the terminology as our foundational ecosystem of little data. Because if we can get that right, then we can start to generate all of these other knowledge artifacts, knowledge-enabled activities. AI becomes orders of magnitude easier if we've got this foundation right first. That's why terminology is really critical from an open air point of view. Now, archetype reuse, this is a paper that is hard to see at the moment, but it's a paper I wrote at the end of COVID. We looked at how a number of different data sets were able to be generated. So the first ones were around just screening for symptoms, and then later on it actually became one that was more around surveillance and also management. We can see that certain, you can see down the horizontal, these are the archetypes, the amount of reuse across the templates. And here are 2 templates, slightly different purposes, but you can see the reuse is different. The first one is the screening. The second one, I think, was actually guidelines for use within one of the hospitals in Wuhan at the time. So we get a lot of reuse, all right? So I'm finding that we get at least 70 to 85% reuse, sometimes up to 100%. It's increasing. Every time we add a new archetype to that ecosystem, the potential for reuse is increasing. So where does terminology fit? Now, I would never describe myself as an expert. In fact, I'm probably dangerous with terminology. But what we need to do is to be able to define the clinical concept with terminology. That means we can equate a problem diagnosis in open air with a condition resource in FHIR, and we know that these 2 things are going to be equivalent. So naming the actual concept is going to be very useful. We could, according to the ISO 13972, be able to actually put SNOMED codes against each of the data element names, and that would be useful. We don't tend to do that because A, we don't have the resources to do it, and it's a huge maintenance thing, but there's no reason why we couldn't do something like that in the future. But where we find the value is where we've got the names, right? The name of a problem diagnosis is clearly something that is value set territory, and we are not experts at that. We need something like SNOMED to be able to give us value sets to be able to use. Similarly, with the variant, what we've got there is it's a DV text, so that's our data type, but the recommendation is coding is preferred where possible. There's the same thing here with the body site. It's the same thing here with the cause. When we get to something like severity, as clinicians, we're actually a little bit more prescriptive. We're giving them a choice. We're giving people a choice of either free text that can be coded at a later date, or we're suggesting instead of the massive list of severity that comes out of SNOMED with mild to moderate, trivial, all of these kinds of things that really are too fine-grained for clinicians to actually be able to have sort of inter-recorder consistency, we're suggesting it should just be mild, moderate, severe. But we give people the option, if you don't like it, you can put in another value set, you can use it slightly differently. And it's the same with the diagnostic certainty. We're suggesting what we think is clinically appropriate for this use case, but we're not locking people in. These can also be coded behind the scenes in the archetype. The constraints are at the moment, though, we have a lot of users around the world, and with my international management hat, I can't lock people into SNOMED. I need to let them be able to use other codes, because if they haven't got a license, they can't validly use it. So we have this tension, and that's part of the reason why I'm here, is to start to discuss about how we manage this kind of tension that we've got. There'll be local codes, there'll be other codes that people prefer, but we're here to work out how to get SNOMED working with open air better. So if you think in terms of the problem diagnosis archetype that we represent on the left, we need the problem diagnosis with a really good value set with all of the problems and diagnoses of really high quality. But we'd also reuse that value set in our screening questionnaire. We would also use it in our differential diagnosis archetype. We would also use it in our family history archetype. So we're providing the context for all sorts of different things, but we're actually going to be reusing the same value set. And I think this is where the reuse of terminology is going to be really important as well. We do a similar thing with symptoms. Symptom sign is an archetype that we've got. We also have a screening questionnaire. We would use the same value set. And then when we come together, where we're going to be actually doing service request, and we want to indicate a clinical indication for why we want this service done, we bring together the problem diagnosis value set and the symptom value set, because our definition is about symptoms, signs, or diagnoses that necessitate that service. It's the same for procedure. It's the same kind of thing, except it might be even broader in case there's things that are non-clinical. So when we get to the point of looking at some of these kinds of things, the community has asked me to talk to you about this issue. This is probably our biggest bugbear and something I've been looking at and wanting for over 10 years. Can we get a pre-coordinated set of body site values? At the moment, we use it a lot. It's inconsistent or it's incomplete, as I understand it. Please correct me if I'm wrong. We have this way of trying to manage it so that we have a body site data element there, but we also have this thing called structured body site, and this is a slot where we can put other little expert archetypes for where we want to extend this. So we need it for problem diagnosis, we need it for the measurement site in blood pressure, so it's the same thing, body site, but sometimes we need to go into more detail. So when we need to look at the anatomical location in very precise details, we need not only that value set, but also some other attributes. When we want to look at the relative anatomical location, so I can say the wound was 5 centimetres proximal to the lateral malleolus, or forgetting my anatomy, I think, anyway, ankle, or the circular anatomical location, all right? So to be able to say there's a reference point at 12 o'clock, and if we're looking at a breast or we're looking at an anus, we can actually say this is where the hemorrhoid was, this is where the lesion was in the breast, so far away from the nipple. This is the kind of challenge that we've got to be very precise, and just having that pre-coordinated value set would be a little bit of magic for us. So that is our major request. This is the last slide. We have clearly use cases which are terminology only, the value sets. We have clearly use cases which are very much archetype or information model structures. It's this grey zone in between. It's this area of uncertainty that we need to be starting to have discussions about how we manage it so that we're actually finding that semantic sweet spot. I think that's the challenge for how openEHR and SNOMED can work together. And that's the thought that I'd like to leave you with. So thank you very much.
Peter, it's over to you. Are you going to use? Oh,
Are they going to be okay?
let's see.
Well, we can switch it.
There we go. Fingers crossed.
That's spoilers. It's fun. Good morning, everyone. I'm Peter Groves-Williams. I'm a technical specialist with SNOMED International. Following on from Michael's broad introduction to FHIR, I'm going to be looking at terminology services and also the specific features of FHIR which play to some of the strengths of SNOMED CT. I know something about FHIR. I know nothing about openEHR, so I was very grateful to be speaking after Heather's presentation there. Also, thinking about information models and code systems more generally, having a code system is like having a dictionary. It's the set of words that you can use. The information model provides you with some structure or grammar. Without that grammar, just putting the words together will result in, we have an English word, gobbledygook. And I have to be careful about using English idioms, so I translated that into a variety of languages there. The Flemish, since we're in Belgium, is a lovely word, klap van de molen. Maybe someone can correct my pronunciation, but that means the chattering of the mill. In fact, we're all used to using information models. Whenever you fill in a form, there'll be a number of boxes that tell you what you expect to find in that box. So we've all seen it, and hopefully the box will tell you what format that information should appear in as well. So here's the top of the FHIR specification. FHIR gets straight into the details immediately, listing out the resources, of which there were 157 in version R5. I find this level of granularity very intuitive. Like when I want to receive a patient, I will get a patient object, and maybe I'd like to know about their last 10 encounters, so I can request as many of those as I need to. And that's very useful when we're talking about mobile applications, that you can just get the number of elements that you require, and perhaps there is security or permission on each of those at that granular level as well. So you don't need to download the entire medical health record. FHIR servers come in two flavors. Either they're concerned with patient data, conditions, and medications,
or they talk about code systems and terminology, and those resources up there on the top right. Many companies have written terminology services and servers which conform to the FHIR specification, Snowstorm by SNOMED International and Onto Server being the two that this panel is most familiar with. So as well as defining these terminology resources, the FHIR specification defines a number of things you can do with them. And Michael mentioned that these are the operations, and these all start with a $sign. Normally, of course, we'd be using some FHIR application on the phone or desktop, and the app would take care of these details for you. But it's also possible to type some of these long URLs into a web browser. And if you get a bunch of parameters exactly right, you can see what each of those operations would give you back. So what I'd like to focus on is how SNOMED and FHIR work together to bring out the best that each has to offer. HL7 hosts a page that details the support FHIR has specifically for SNOMED CT. Things like recovering the logical model, the parents and attributes of concepts, and also using the power of the expression constraint language, ECL. Now, I'm not going to have time to go through every call you could make to a FHIR terminology server in detail, and unless you're writing software, that would be a detail that you do not require. But I've got a short link to this presentation at the end, so if you'd like, you can click on some of these links in your own time and see how a terminology server behaves. So the lookup operation lets me recover the details of a concept. In all of these requests, you'll see some parameters come up in common. A SNOMED identifier, of course, is just a numeric number, so we also have to say what code system that applies to, so I've put that in red there. And that might be a specific version coming from a particular edition on a particular date. So that tells you that that code is a part of SNOMED. But I said I'd talk about specific SNOMED features. So in this slide, I'm showing you how you would request the normal form property, which would give you back the model of this concept using SNOMED compositional grammar. So this is how you would model a 500 milligram paracetamol tablet. And that is pretty terse. And in fact, the FSNs that are in there are really just a human courtesy. We would normally often transmit those with just the codes. So it really is for computers' consumption. So this is not a part of the FHIR specification, but just to say if you're looking for a concept, maybe you don't know what country that exists in. And the URI specification, which is at snomed.org/URI, defines a way to look those up. These URIs are just identifiers, but obviously they're also URLs. So it seems like good manners to have that go somewhere. So if you were to have a SNOMED ID and you click on that, then you would go through. Initially, it would just go to a browser because you're working in Chrome or Edge. And since we need to give it a hint, we say the format I'd like to get that back is in FHIR. So you'll go to the terminology server at that point. So once we have code systems, we can talk about a set of codes, which in SNOMED we call simple ref sets, but in FHIR we call those value sets. And value sets in FHIR also have additional levels of metadata built into them, much more than simple ref sets. Like other subsets, you can specify concepts in one of two ways. Either you enumerate each code that you want to include, or you specify a set of rules that are evaluated at runtime which work out which concepts to include. And we call that an intentional definition. And the advantage of that is that when your underlying code system changes, maybe there's a monthly release of SNOMED CT, then that evaluation will change over time, and the concepts that you return will change. You can also set that in your FHIR value set and say, no, I only want you to use the specific version on this effective time. So the value set object that we save, the definition, here's one I saved earlier for allergy intolerance. When we want to obtain the list of codes that it specifies, we use the expand operation. And to highlight one of SNOMED's strengths in internationalization, I'll use the force system version. So whatever we defined this value set as, maybe the international edition or some other country version, I'm saying I want to override that and use the Swedish edition. And I want you to give me a Swedish preferred term back, or if it's not present, pull back to English. So value sets can be defined, uploaded to a terminology server, and then expanded when required. But there's also the option to define your value set as part of your request. All you need to give is the rule that you want to run. And in our case, I'm going to give an ECL selection that says, give me all procedures that are performed on the heart. And you get about 1,800 there, which is far too many to scroll through. So I can also add a term filter. So maybe the clinician has started typing something they're interested in, MRI in this case, and that will cut that list down to about 27, which makes your application safer because the clinician is only seeing the results that they're interested in. And it's also responding faster. We're not looking through things that aren't relevant. So I said that normally you wouldn't see all these parameters. More likely you're using an application, and we have a demo prepared, the color of which is a little, that is snomed.org/UI. And that's a lot of user interface to fit into a single slide. So you could have a look at that in your own time. But I've brought up the application there. And also the section at the bottom, many of you probably wouldn't ever do this, but if you press Control, Windows key or Mac key and I, you bring up the developers tools. And that shows you all the calls that the front end makes to the back end. And this is sort of the point of FHIR, is that this is an industry standard API. So there's a box in the top right there. And I can drop that down, and I can either say I'd like to go to Onto server, or I could go to a SNOMED international hosted server. And they work just the same. Not quite the same, because if I make a request to an Australian server, I will get back the Australian concepts in addition, by default, in addition to those in the international edition. And in my case, my browser was running on my laptop. So I asked for British English. So I get appendicectomy rather than appendectomy. That's just the UK spelling there. I've spoken for so long off the cuff, my phone's locked up. That's good. Oh, so the other thing there is that the box that I typed into, that was a procedure. Now, we've only got one appendix, and SNOMED knows that. We have a reference set that says which body structures can be lateralized. And since it knows that your appendix is on one side of your body, the laterality box will gray out. And so that makes things safer, that you can't say something that can't be true. So a very common use case for a terminology server would be that you've received some FHIR resource and you want to check that the codes contained are actually valid. So you could do that either at the level of the code system, or you say, well, in that particular field, we only allow this set of codes. So you can validate against a value set as well. In this example, I'm using an implicit value set, so I can change that ECL each time I make the call. Now, of course, medical practitioners probably never want to see SNOMED IDs. They'll be typing or selecting text on a screen. But it's possible that something should go wrong in either their typing or in the storage of that or in the transmission. So we also can send the text that they've selected, and then we'll validate that as well. Now, if we are passed a synonym, we'll say that that is acceptable, but perhaps give back a warning. But if the text is completely wrong, then we will invalidate that code. So I've generated slides for each of these examples and all of the operations, but they start to look somewhat similar after a while. The system is there in red, and then you'll pass a code. But one that's quite interesting in terms of exposing the internals of SNOMED CT is the concept map translate operation. Normally, this would be for something like translating between SNOMED CT and, say, ICD-10. So we say, what is my source system, and what am I going to? But in the case of the historical associations, I can actually see those exposed by FHIR by saying I'm going to map from SNOMED to SNOMED, specify the ref set for the same as association, and then I can find when a concept has been inactivated, what should it be replaced by. So moving on to newer work, no presentation this year is complete without showing our collaboration slide. And the section that I'm particularly interested in are those extensions in green at the bottom with NUVA. Hi, Susie. I did ask for permission for NUVA, NPU, and LOINC. So what we're doing there is taking another code system and transforming it into a SNOMED format as an extension, creating new SNOMED concepts for each LOINC or NUVA concept, and giving them both the SNOMED identifier, and they retain their original code from the host code system. Now, this really is the holy grail, the Saint Graal of interoperability for me. And FHIR provides great support for this with its codable concept data type. So we can transmit a message that contains both the SCT ID and the NUVA code. And this is not a map from one code system to another. We're saying this is exactly the same entity expressed in a different format. Michael has some slight indigestion about us doing this, but we're saying that is exactly the same thing, and those codes can be used in a transparently interoperable way. Now, once we have these other code systems in a SNOMED CT format, we can start to use SNOMED features like ref sets and ECL to define value sets in ways that just aren't possible in those original code system formats. So a couple of LOINC examples here. I've asked that you select all concepts which are both something that a clinician could order and are concerned with blood specimens, or some really scary ECL, the reverse operator. I'm asking to determine for those orderables what all laboratory techniques are in use. So to sum up, code systems and information models need each other to express meaning. Without using the two together, we end up with, Brian? Gobbledygook. Gob. Advanced features like SNOMED expression constraint language can be used to define value sets using rules, which naturally evolve over time as the underlying code system changes and grows. Specifying those rules at runtime saves the costs of maintaining value set objects and can keep applications flexible, agile, and also safer and quicker to use. Code system transformations allow us to use powerful features of SNOMED CT in ways that haven't been previously possible. And finally, just to advertise our SNOMED on FHIR working group meeting, we hold those every second Tuesday, 2000 hours, or every fourth Wednesday at 1000 hours, which is a little easier for other parts of the planet. And those meetings are completely open. They're for the benefit of anyone who would like to discuss using SNOMED and FHIR together. So we'll maybe see some of you there. Okay. Thank you very much.
Okay, we've got 20 minutes for questions before we go to morning tea break. And I do think a few questions are in the chat. Okay. I'm not sure if you guys are happy to answer questions from the table. And Susie, you might want to jump in if we get into some that are about collaboration opportunities as well. Yeah, I know. I'm glad you're right there in the front row. So openEHR natively supports a model of meaning bindings at the data element level. What's the story on this in the FHIR world? So looking at you, Michael, or Peter, who would like to answer this question? Please, if you have got questions, just while you're thinking about the answer, menti.com, if you're not still already in there, 75325100. We'll use this to get the questions in, just to make sure it's equitable for the all and those online to post questions via Menti as well. So please pop your questions in the Menti.
I would like to understand the question.
Did someone in the room ask the question, or was it someone online who asked the question? Yeah, please. Would you like to repeat the question?
Use the mic.
If you could just use the mic, please.
Oh, I have to push it.
Yes.
Okay, we finally figured out the technical bits. As Heather demonstrated in the CKM, for an archetype, you can bind a data element to a concept, for example, in SNOMED, to say that this is the cuff size. FHIR has the same sort of structure as an archetype, but I've not been able to find any way to bind, say, a SNOMED concept to a data element in a FHIR profile.
Yeah, okay. I thought that might be what you were getting at. No, but I think there's a fundamental challenge there. Yes. Okay, so technically yes, but I think the challenge is that, and this is an opinion, right? I don't know what that actually buys you. You can say, for example, condition.code, you might want to bind that to what? The SNOMED code for clinical finding. But the closer thing, especially for code type things, is actually what you bind, the value set that you bind to that element, because that's, you're saying this is the range of things that are sensible responses for this field. If you're trying to do that sort of data element binding, so it's a model of meaning binding, that might help you say that this field in this model corresponds to that field in that model, but those fields exist in the context of all the other fields in the model, and that skews the meaning. So the context can't be narrowed down to, and this is something I was going to talk about in the next section, the meaning can't be narrowed down to just the data element on its own.
No, exactly. But for a blood pressure expressed in a FHIR profile, or a blood pressure expressed in an openEHR archetype, they are trying to express the same thing at 3 levels: the top level clinical concept, the data element, and the value sets inside it. When I handed that problem to my integration developers, who are really good at making FHIR-based integrations, they got really confused because we had an EHR system that was openEHR based and expressed this in an archetype, but I didn't know where to put this in the FHIR profiles. It doesn't help, of course, that the FHIR profiles by default aren't that rich and nobody wants to use extensions. But it's simply a way to express that this is the same data element in this model and that model, so that integration developers actually can use this without being clinical experts and discussing the semantics of it.
Anna.
Yeah.
I'm not sure if Alejandro is in the room. Is he? No. Okay. But what's something we did? Is he? Okay, Alejandro, I want to talk about the model meaning binding in the questionnaires, FHIR questionnaires. So one place where FHIR is really excellent at model meaning binding is in the FHIR questionnaire resource, where when you can create question answer, those questions you can assign a SNOMED code on the actual question. So if I think it depends on the content, because I agree with Michael that if you have an allergy intolerance resource, the overall context of that resource is given and it's fixed, and you can define your own mappings then of what concept in SNOMED CT would you use. But I think that doesn't need to be explicitly represented in that resource because it's given by that context. But for a FHIR questionnaire that can be used for many different purposes, it makes very good sense that you're able to do a model meaning binding, because you can create a questionnaire for one purpose and another purpose. It's more generic, and when you then tailor it, makes good sense to use SNOMED to do the model meaning binding, and FHIR supports that for that resource.
Yeah, just to add, I think there's a fundamental difference between the standards, because you don't have a blood pressure FHIR resource. The FHIR resources are like at a different level. We have an observation FHIR resource maybe. And when you want to capture a set of observations in a context related to each other, in FHIR, you actually need to use like a custom resource. And that custom resource would have the model mining that you're referring to, this, for example, the questionnaire. But I think this is why openEHR is so good for representing clinical things that you record every day and model the clinical meaning. And FHIR is so good for exchanging because it's less variable and you have less variety of resources. Yeah, so I think it's a combination of, it's a different nature, and we need to understand how to translate from one to the other. But you cannot do exactly the same with both. And it's a good thing, I think, because if you want to be very friendly for the clinical record, that's more difficult for interoperability. And if you want to be really useful for interoperability, you need to be more strict, and you're not that flexible. So I think it's understanding how we play together.
Next question was around the FHIR intro, skipping, profiling, implementation guide tooling, and resource validation. These are central features of FHIR, setting it apart from CDA. So, Michael, why did you skip those topics? Probably because I only gave you 20 minutes.
Yeah, I only had 20 minutes. I had to pick and choose. So and leaving out profiling was perhaps a mistake. So I can talk about profiling. So I did talk about extensions. Extensions allow you to identify either new elements, simple elements with simple data types, or complex elements with complex structure. So effectively little mini extra models. And I also talked about binding. And what implementation guides do is, well, what profiling does is it allows you to computably express those things. So you define what your extension is. You can define bindings to value sets. And then for a given problem, so perhaps you want to have, because you don't have a blood pressure resource, you want to talk about how do I express blood pressure in FHIR. So I say, well, you use the observation resource and you put these codes in these fields and you have constraints on these things. And we want to record this extra information because it's in our openEHR-based blood pressure model, but there's no slots in an observation resource. So in the profile, I can say computably, this is where you put those things. The profile then gets an identifier, gets a URI that says, this is the identity of that profile, and I can then attach that to the instance of an observation to say, assert that this observation conforms to these constraints expressed in the profile, and therefore it is a blood pressure. And then there's tooling that will check that. So if you send me an observation and I say, well, I don't know what this is, but maybe it's a blood pressure, I can ask that tooling, does it conform to those constraints? And if it does, well, then I can infer that, yes, this is a blood pressure observation, and then treat it as such. So profiling and implementation guides allow you to do that extra level of modeling that you need to go from the very general abstract FHIR resources to problem-specific or ecosystem-specific additional constraints.
Question for you, Heather. In openEHR, has any research been done about the size or shape of the semantic grey area on the last slide using different potential terminologies?
No. So my answer is very simple. Look, openEHR has been essentially standalone. We know we need terminology, but we've been agnostic towards any particular terminology. We have certainly built the archetypes to be all of the data elements that a clinician might need. We have tried to be as inclusive of all like local terminologies. We're well aware that it's all very complex and we don't prescribe it. I think potentially we can, as we start to develop this collaboration with SNOMED, we can start to be a little bit more prescriptive, and I think that is part of the investigation that I would like to do. That slide was something that I developed with Mikael Nystrom and some of his colleagues in Sweden probably 10 years ago. I think we had a version of that last slide about that semantic grey area. And I don't think we've progressed it at all with SNOMED or with any other terminology. So this is, I think, the art of what we need to do in this collaboration is to work out how to get the best of both organisations and how we can bring all of this together to work and optimise our health data foundations.
Okay, for this question, how to avoid the semantic overlap between the information model and SNOMED, we're going to hold this over because this is actually the topic after morning tea where we'll be, Michael will be talking about bringing it all together around information models and terminology binding. So we won't answer this one now. So this is going to bring you back for morning tea. Let's see if we've got any others. I think you're probably also going to cover this after morning tea. Challenges when implementing. Yeah, hold that one over too, just so we don't, spoil the surprise. Any other questions from people in the room? Or if everyone's just really keen to get to coffee break, knowing we've got to go up the stairs, down, over and down the stairs. Okay, excellent. We might cut it a few minutes short now so everyone can get a morning tea break, get a coffee. When we come back from morning tea, Michael will be presenting around information model and terminology binding in more detail. We then also have a number of countries who are going to do a quick case study of what's happening within their area. But if there's anyone else in the room who is not on that list, we certainly have time for a couple of others to actually jump up and share their case studies as well when we come back from the next session. So thank you very much, and we'll see you after morning tea. So we'll be back here at 11 a.m. Thank you.
Relatief. Oh ja, er zijn nog veel kleine issues in. Echt in Excel staat zo standvol met formules dat ik mij al kan voorstellen dat die gasten wel lust hier en daar foutjes hebben gemaakt. Er zijn niet zoveel kleinigheden. Dat is een beetje
I think we almost have everyone back in the room, and I can see the numbers holding steady on the online chat. So we'll give it one more minute and then kick off.
Yeah.
You can see just a few more coming in the room. If you weren't in here before and you're now joining, there are some extra chairs over on the side to grab those chairs and just grab a seat. We were a full house. I think we hopefully have enough chairs. We may have lost some people after the first session, so we'll see how we go. I think we look like we have a good number, so I think we'll get started. So we had a lot of theory this morning around openEHR and FHIR Terminology Services. We now want to get into the kind of more applied side of things. So Michael's going to kick us off with around terminology bindings and information models. But then after that, we're actually going to have 6 rapid fire case studies from countries and one vendor to actually apply this around how they're doing it within their own countries, within their own products. And then if we've got some time, we've asked Alejandro from the SNOMED International Implementation Team to show us where some of the really cool demonstrators are, the tools that you can actually play with yourselves to start to understand this more. So we've got a good 90 minutes ahead of us. So Michael, I will hand over to you.
Thank you, Kate. This is not going to be a 101 on terminology binding and information models. This is more a flavour and some of the complexity and where and how things can go wrong and why this is an important thing to address. And why am I not able to? Okay, so I thought I'd start with a real world example of the kind of thing that happens when you have no binding or very poor binding. And in this case, this is a system that was deployed around 2010, I think, 2010, 2011. And the binding for presenting problem field was just to SNOMED. Right? It had to be a SNOMED code. That was it. And so that's a binding, but it's not a good binding. And so what was happening was people were recording data and people were coming with influenza or influenza symptoms, and we needed to look at the data of, well, we need to predict what's happening in the coming flu season, and so we need all the diagnoses that are flu-like symptoms. So not diagnosis per se, but presenting problems, symptoms, etc. So when we looked at the data, we got codes from all over SNOMED. Now, to explain what's going on here, all the yellow circles represent inactive concepts. And then we've got different hierarchies. So we've got organisms in there, we've got findings, we've got substances, and we've got procedures. These turned out to be all the codes that were in the data that were indicators of flu-like symptoms. And to sort of interpret the structure there, you probably can't see very well that there's some tiny white blobs in each of these clusters. They represent the root of that hierarchy. So this is the procedure concept, the substance concept, clinical findings, organism. This would be essentially SNOMED concept because these don't have hierarchy, and these blue blobs are artificial clusters because there is no hierarchy in the inactive concepts. So you can see this is a mess for anyone wanting to actually consume this data to do anything with. Probably okay for a human to read the stuff and interpret it on a one-by-one basis, but otherwise it's a mess. So binding and good binding is really important to have actual usable data. Don't ask me what's happened since then with this deployment and whether it's improved. The other key thing that's really important with terminology is, as we talked about in the previous session, is context, because context changes or influences meaning. And one of the examples of this is if you have a pick list, a very short pick list, a person has to choose a value from that list, and inevitably they end up choosing the least worst value. All right, because you have to choose something, and so you choose the thing that's as close to what you want to say as you can find, but it might not be what you want to say. So you need to be really careful about constraining people's choice, and also the meaning of the concepts shifts depending on the context. So if you take the SNOMED concept for appendicitis, you might think that it means the patient has appendicitis, and that is the default interpretation of that code. If you put it in a family history resource, then suddenly the meaning of that code shifts. It's now talking about some family member. If you put a date in the past or a status in that resource that says that it's suspected or it's resolved, then suddenly the meaning shifts again. So need to be very careful about those sorts of things. And that comes into the fact that when you're defining the value sets or the sets of codes that you want to bind to a field, you have to take into account the field that you're binding to in the context of that field. Defining a value set on its own without knowing where it's going to be used and where the binding is going to happen is, except for very broad general value sets, it's a very slippery thing to be doing. Then the other thing we need to deal with, and this relates to one of the questions, is the potential conflicts that come up when you have the information model crossing over with
12 uur. Als dat oké is voor jou.
interpretation or definition of the code itself. So if we take here, we look here at the condition resource. FHIR condition resource, there's condition.code, and that says this is the condition we're talking about. That's fine. But then we've got this body site. Now, of course, we know that it is possible to put arbitrary body sites in there, and they may disagree with the body site in the pre-coordination of that code, if there is any body site there at all. What does a receiving system do when it gets a record like that? Can you control for that? You could attempt to do some very complex bindings, do some parameterized value sets. So this is a feature in FHIR where a value set can have a parameter, and you can in fact do something like bind the code to a parameterized value set that says only codes that are compatible with the value of the body site field, and use that to do validation. Maybe you could use that in a data entry scenario. This is a long road that you might go down and build a very brittle system, might be very precise, but it is a problem. And so when you're implementing, you need to account for this. Can you rule out conflicts? You probably can't. Conflicts come in the semantics, and we don't have enough handle on that. You may get some traction if you apply AI to that problem in a validation context. But this is kind of just a built-in problem because these information models, there is an information model sitting behind all terminology, even if it's not explicit. There is an overlap, and you just can't get away from that. And there is really nice demonstrator from SNOMED International. Alejandro will probably recognise this, which sort of illustrates some of this interplay between the information model and the concepts themselves. And I don't know, I might zoom in on this. So here we have some sample SNOMED concepts, and if we select something like family history of asthma, here's how this might be represented, or in fact is a representation of the full meaning of this concept in a FHIR resource. So it's a family member history. It's about a patient. It's a fictitious patient, but we have the relationship of that person to this family member and the actual condition. And we know that it's the implied current or past because there's nothing to indicate other than that. And it's known present, again, default interpretation there. If we look at something like suspected autism, here we have a condition again. We have the code, which is this pervasive developmental disorder, but we have a status, a clinical status of unconfirmed. So that's where the suspected comes in. Now, you can probably, to some extent, implement a number of those transforms, but that's really complex, and you probably don't want to be using these sorts of findings with explicit context, or the really complexly modeled concepts in your interface or in your records, because the information model is a better and more explicit way to represent and carry that information. The other thing I wanted to talk about was binding strength. So this comes from FHIR. So these are the FHIR notions of binding strength. And I've talked about binding as if we all know what binding is, and it's just, here's a value set, so a set of concepts, and they are the valid things for this field. But there's an extra layer of nuance, and there's a couple of extra layers of nuance in here that are really important. The first level of this is captured in FHIR's binding strength. And there are 5 binding strengths here required. And that means that this is the strongest thing. So the value that goes in this field must be from this value set. If it's not from this value set, it's not valid. All right, so it's a very strong statement. It sets explicit boundaries around things. And that's appropriate for a number of use cases, things like status and so forth, where you really do have a very fixed, simple set of things. It's not going to change in different contexts. The next one, which is quite common, is extensible. And so this is saying, for interoperability purposes, and that's what's driving this, the value must be from this value set if what you need to express can be expressed using a value from this value set. But if you need to express something different, then you can choose a code from outside of the scope of this value set. So it's kind of guiding the data towards a fixed set for ease of interoperability and so forth, but it's leaving some room at the edges for exceptional use cases. So it gives you an out. And then preferred is kind of the softer version of that. It says, we'd really like you to use a value from this set, please. But if you don't want to, well, you don't have to. So that's kind of the sort of strong encouragement, but we're not going to force you. And some of these different levels of strength are appropriate for different contexts. So if you're in a very broad context where you don't know much about the real end use cases, and this might be the case of like a national base IG or a core IG, then preferred is a way of saying, we'd really like you to stick to this set, but you might have a specific use case where that's just not appropriate, and so you can do something different. And then there's a couple of other bindings, the example and descriptive, which don't say anything other than here's some illustrative stuff that that might help you understand what is appropriate or what the meaning of this field is. So it's just there for essentially documentation purposes. The thing about these binding strengths is they're really about interoperability and validation. So about what you're allowed to send and what you should expect to receive. They don't really help you with a number of practical implementation issues, like what should you do in a user interface? What if you want to constrain the set of values that people can select to this set that's active in today's version of SNOMED, but you have to cater for all the historical data that used now inactive codes and was created previously. There's nothing here that allows you to do that. So FHIR's introduced another level of binding strength. These are the additional bindings, and this is carried in extensions. And you see there's a whole lot of other kinds of binding strengths here. Now these, obviously, they have to work together. These bindings you get, right? And they're not optional. If they're specified, you've got to abide by them. These apply in addition. So, and they're variously compatible. So some of them don't make sense in combination with the other bindings. So maximum might say, you might use in the context of extensible or preferred, and you say, here's my value set. It's this subset of SNOMED. But because it's extensible or preferred, you can have other codes. But you might want to say you can have other codes, but only if they're from SNOMED, or only if they're from a particular hierarchy in SNOMED. So maximum allows you to put that extra constraint, like an upper bound on where those additional codes can come from. Minimum allows you to say things like, if you're a receiving system and you get this data, you have to understand the meaning of these codes. If you get one of these codes, you need to know what it means. You need to be able to interpret it. So this is starting to touch on things like conformance. We go down to something like UI. UI is a really interesting one because this is addressing not what's valid to exchange, but things that are relevant to the data capture end of the story. So this is where you might have the full set of codes that are valid for interoperability, but actually the preferred set of codes may be in a given context that you want to render or make available through a user interface. Something like starter is a bit closer to the example bindings, sort of, here's a good set to start with, documentation, but your use case may vary, go from there. So there's all this additional level of nuance in binding that you need to perhaps consider when you're doing this binding thing and designing your value sets. You need to understand whether your use case is one of conformance, what's actually valid to transmit, or whether your use case is one of, I want to guide the data collection process so that I don't get nonsense in my data set, or I don't get outdated concepts in my data set. So, talked a lot about binding. Thought it'd be useful to do a little demo. And if I can find it. Aha. Okay. So, I was going to do an example of building a form on the fly and binding to a value set and so forth. The builder that I wanted to use is not available to me at the moment, and the NLM form builder is a bit fiddly. Instead, I have one that I prepared earlier, and I thought I'd just talk you through what's going on and the mechanics of what's going on in this scenario. So what we have here is a FHIR questionnaire. So it's a long, complicated resource, but it's a FHIR questionnaire. And one part of the questionnaire has this medical history summary, and I've just lost the section. There we go. And so it's just asking for one or more conditions to be entered, plus some additional information like when was the onset, what the status is. So is it active, is it inactive? Do we know what the status is? The key thing here is we haven't built in a fixed set of codes. What we've got is a binding to this answer value set. In this case, and here identified by clinical condition 1. So in this case, the value set is actually not sitting somewhere in a terminology server. It's actually embedded here, contained in the questionnaire. So it's carried with the questionnaire. So it's a self-contained resource. There's actually a couple of value sets in here. Here's clinical condition 1. It's got a set of metadata, and then it's got the key thing, which is how this value set is defined. In this case, it's defined as being a SNOMED value set, and it's requiring the concept to come from this reference set. So this is saying any of the members of this reference set is a member of this value set. And so when I jump in here, I can do a search for a condition. That search is sent off to the terminology server. In this case, what we've done is we've configured in a terminology server to use. So it just says, when you're doing this form, use this terminology server. And there's one of those operations that Peter talked about, the expand operation, is being called. It's being passed that value set definition and this string that I've typed here, the T1DM, and it's found all the matches of concepts in that value set and brought them back in a hopefully best match order, and we can select the appropriate concept. So we've got a very simple way of expressing what we want to bind to, and then capture allow the user to have a good experience of searching and selecting. And that's pretty much as simple as it gets. This definition is an interesting one. It's relying on the fact that there was a predefined reference set that was suitable, that came along with a SNOMED distribution. That's an interesting idea, because here we've got a questionnaire that's the context for the binding. That reference set was defined by someone else. They don't know about my questionnaire. They don't know if, what constraints I might have. But if I did have other constraints, if I did have additional things that were relevant for the questionnaire that weren't captured by that value set, or things I wanted to exclude, then I could write a slightly more complex value set definition here, tweak the membership to be actually suitable for my context, and then I would get that seamless behavior, and I can do that on the fly. I don't need a new SNOMED release to come out to change that set of available concepts. I can adjust things as appropriate here. And so here, this is another form of binding. So this is binding in the context of a questionnaire. What comes out of a questionnaire is a questionnaire response, and then one of the things you might do with that is map some of those answers back into FHIR resources, and when you're doing that, you may be subject to further constraints around binding. So actually the definition of this, this value set here may need to account for what the bindings are in the target of those transformations. Now, there were some questions that I was going to address. I think I've addressed the overlap between the information model and the terminology meaning. The other question was the challenges. That's right, the challenges when migrating from V2. I'm not a V2 expert. Who is I going to look at? Is Dougal in the room? Not yet. Okay. He's just stepped out, did he? Timing. Yeah. So I'm not sure what specific challenges there might be. Obviously, if you've got an existing data set with an existing set of codes and you need to transform from that model to a FHIR model with different bindings, so SNOMED codes instead of what you had before, you're likely to need some kind of a map. That map will need to account for what your target model's bindings are. So you can only map to codes that are in scope. And so that scope may be, well, this subset of SNOMED. A number of those maps will be generic. So, if you've got well-known codes that are commonly used for particular types of V2 messages, then there will be a standard mapping for what they should be in SNOMED. And so one of the things to do would be to go and look to the existing V2 to FHIR transforms. And in those transforms, there will be concept maps. And so there may be a concept map there that suits what you need. There may also be concept maps that don't suit what you need, but give you guidance on the direction you need to go in. But really, I think that is just a straightforward, as far as maps ever are, a straightforward terminology mapping challenge. Okay. I think I've been. We'll end there and move to case studies.
Thank you.
Thank you. My name is Jean-Michel Paul-Fleet and I work at ES Platform in Belgium, and I'm responsible for the standardization team. So in our team, we are responsible for the publication of the FHIR implementation guides that allows interoperability in Belgium and in the future in Europe. So when we do publications in Belgium, the first very important element is the business constraints. So we have one of our institutional partner, RISIF, NICDI in Belgium, who is responsible for the business analysis that comes before the FHIR implementation guides and before the definition of the SNOMED value sets. And this work is done before. We have a very strict governance process in Belgium. And all of the partners in Belgium, they know this process and they follow it when they have new projects. So first is the NICDI RISIF institution that is responsible to create the business documents that are a source for our technical and business work groups defining the FHIR implementation guides and the SNOMED value sets. This document, so the business documents, they are published on a website where there are a lot of literacy and documentation and so on available there. And there is a link to our publication of the implementation guide, so the screen in the middle. There we have a list of all the implementation guides that are published. And also always a reference to that business documentation. Of course, the business documentation is very important to understand, as you said, the context and so on, because just publishing technical stuff is just completely useless. And the implementation guides that we publish, historically, they included the value sets. So in the implementation guide itself, because at that moment we didn't have terminology infrastructure available in Belgium for SNOMED, but now we almost land on the implementation of that infrastructure. So the future implementation guides that will be published, and we need to make a migration of the existing implementation guides. They will no more include the value sets in the definition of the FHIR implementation guide, but make a link to the value sets available in the terminology infrastructure. So in the value sets, so that's the third part of the publication. So it's under the responsibility of the NRC in Belgium, who is making available all the value sets that are referred with the reference and the bindings into the FHIR implementation guides. So from the logical model, the business part is responsible for the logical model. So in their business document, they are making this logical model in a visual way. Step by step also, we are trying to publish also those logical models in the FHIR implementation guides. So we have a more structured way to represent those logical models. Some very old implementation guides are still missing that part, but we are correcting that step by step. So from the logical model, we are building the technical interoperability model. So the FHIR implementation guides, and in those different data elements, we are making the bindings to the different semantic value sets. And we push in Belgium to have that in SNOMED globally, but for very specific use case, like for the labo result, we push for LOINC. So in the definition of our implementation guides, we have the links towards those value sets. This slide is quite complex, but it's just to show how far we went when we decided to go for a FHIR governance. So this is the full process from project definition, so business opportunity, towards the publication of the implementation guides, value sets, and what is the work that we do together with our partners to land with a very mature publication. So globally, what we do is that we have all the business parts, so the left of the screen, a lot of process validation also with the different institution. We have to present the project and to agree that this is a project that has an interest for the Belgian ecosystem. And then we move to what is in the circle. So it's a kind of agile work between the business work group and the technical work group. So there, based on the business specification, we try to move forward to have something mature in terms of technical interoperability, but also the definition of all the value sets needed to support this technical implementation guide, because just the technical implementation guide without value set, as you explained, is just a Pandora box open for anything that you can write in any field. So that's very important that we specify as close as possible, depending on the context, what will be the value allowed for one specific data element in the context of that specific project. So that's the main part of the process. So it's we have around 6 to 8 weeks working on that with different groups. Weekly groups that are working on the finalization of the technical interpretation of what is needed, but also then there are questions and probably some adaptation needed at the business level to be sure that we can land with something that is strictly feasible in terms of technical implementation. And then on the right of the process, we try as much as possible also before the publication to have what we call coalition of the willing. It's also called POC if you want. So the goal is to take some implementers in the field. For example, in the Labo project, we made a coalition of the willing with 2 software developers at the Labo side and 2 software developers at the GP side. And we asked them, okay, this is our draft specification. Now put your hands on the keyboard and start to implement that we can cover 99% at least of what we do in Labo. Are we sure that we can translate them into FHIR resources? And we can check with the receiving softwares that they can get it, they can interpret it correctly, they can show it correctly. And then we had also a kind of agile process at that site. And some adaptations have been made in the technical FHIR implementation guide as draft to be sure that at the moment we are ready for the publication, we can come to our market to say, guys, this is something that has been improved, that has been implemented not yet in the field, but at least with different software, different partners and so on. We try to do that as much as possible, but sometimes times constraints, budget constraints are avoiding this part of the process. And at the end, when everybody around the table does agree with what we have in our hands in terms of business document, business rules also, technical implementation and value set, then we go for the publication and we can ask our market vendors to start to work on that implementation with all the parties involved in the ecosystem. That's how we work, and up to now it's quite good. The results are good, but it takes time. All the question about mapping values that are already there is always a problem. As I always said, ideally we should have an international definition of what is a concept, and then for EHDS a European definition of that, and then we can have a national interpretation of that. And then we start to develop, to work and to record data, but that was not the case. We have data for decades now, and we have to move forward with all of that. You're welcome.
We'll hold for questions at the end, and the Menti link still holds if you've got questions to put back in that Menti link. Kylene, over to Australia.
Thanks, Kate. Hi, everyone. My name's Kylene. I'm from CSIRO, but I'm working as the clinical design lead and deputy lead of Sparked in Australia. And Sparked is Australia's FHIR accelerator, and we're working on a couple of products at the moment. So I just want to, okay. So as we are a FHIR accelerator, we're obviously working on our AU core, which is how we exchange data. So thinking about what is the data, how should it be structured and accessed and shared across the systems. But we know that if we just exchange data, we can exchange data, that's great, but what about the quality? So we are also producing the Australian Clinical Data for Interoperability, which is really defining what that clinical information is, what should be included for data entry, data use, and sharing of information to support patient care. And as part of the Spark program, we've got two streams going on, a clinical stream and a technical stream, but it's really important that those things work together. So we've talked a lot about FHIR this morning, but I wanted to speak a little bit more around our AUCDI, our clinical data for interoperability. And as I mentioned before, it really is defining the what. And this is the current scope of AUCDI. We've made 2 releases of it. And this is the national clinical data model for Australia, and it then feeds into the AU core, which is our national core FHIR IG. So as you can see, the scope here is pretty. We started off with the mantra of core of the core. So we've got things like problem diagnosis, we've got procedures, we have education, we have some social determinants of health behaviours. We've slowly increasing. So we were really working on an agile, growing as we start to build out those requirements. We originally started with that core use case, but then we've slowly added additional use cases, including patient summary and chronic condition management. And we know that we can't do everything all at once, but we're starting small and building out as we go with our clinical community. So the only reason we were able to go so fast so far is because we really did leverage openEHR or openEHR that Heather was talking about this morning. So AUCDI leverages the openEHR archetypes. We take the clinical information models that are there and we bring them to our clinical design group. And for us, we're not using the maximal or inclusive, but we're using that as a roadmap to know where we want to go and cutting it down to what we need for now and knowing that we have a really clear pathway to take that to. So AUCDI leverages openEHR, openEHR, and it embeds SNOMED. So we do some terminology binding even within our clinical data model, and then that gets passed to our FHIR IG. They're building out the FHIR Terminology Technical Design Group. They're building the AU core, and they are also binding SNOMED there. And we are building other national FHIR IGs as well, and they're also binding to SNOMED. So for us, terminology sits on both the clinical side and technical side, obviously. This is what it looks like within AUCDI. So currently, AUCDI is just a document. That's what we needed at the time, but we are starting to think about how we're going to represent it in more machine-readable ways or other ways, but right now it looks like a document. So for problem diagnosis, you can see here the data type is a codable concept, but we do recommend a clinical condition value set, which is published by our National Clinical Terminology Service. And we also provide examples of SNOMED codes, and you can see the same reason for encounter. There's a value set that we recommend. Where there's no reference sets yet, but there is some SNOMED codes to support the content, we provide those. So we do still state that SNOMED is the preferred clinical terminology in Australia, but there are some examples of the codes that we are including, and we are working with the NCTS to build out national terminology sets for these as well. So here are 2 examples here. I think I just kind of wanted to reiterate, for us, it's really important that we do bind the terminology and get the appropriate terminology, just because you do need to think about how all the parts fit together. So I think this whole pre-coordinated thing, I think we do need to think about it. For example, our model for medication use statement and our medical imaging request data models, they do have bits that are traditionally all linked together because of maybe how your interface has always worked, but our information model starts to split some of these out. So we do need to make sure that we get these bindings correct. So I just wanted to provide some examples there of where the different terminologies in different data elements all need to work together to make a request or to make a statement. And And I think that's all I had. I was really quick.
Peter from the Netherlands in the room. Where's he gone? I've got his slides, but I can't present them. Here he comes. Fantastic. Think you're going to use your own?
Yeah, I didn't prepare.
Brilliant. Thank you so much. Well, you did get thrown on the spot this morning.
Yeah, I didn't prepare a presentation, but I'll do it live. If it works. I'm in the Zoom meeting. I wish. Yeah, you should. Okay, let's try this. No, still not. I think I can. Okay, so in the Netherlands, we, well, like in Belgium, we don't start out with FHIR. Of course, we start out with clinical information models. We call them ZIPs, zorginformatiebouwstenen. And they are defined according to their own process with the proper governance. And there are quite a lot of them nowadays. And this is the complete list for the latest release. So if you look at for example, the problem zip, you'll find a data model and with the relevant concepts. And you see that in these clinical information models, there's also binding to the value sets. So, for example, problem name, which is really what the problem is about. If you look at that, there's quite a lot of options to encode it with terminology. There's ICD-10, SNOMED, well, the Dutch Nursing Simple Reference Set, so that's a subset of SNOMED. There's DSM, some things I don't know. So this is the allowed range of codes that you can use to code the problem itself. If you look at, for example, the verification status, there's a small subset of SNOMED and also an unknown code from the null flavor code system. So we take this as the input for our FHIR profiles, and we publish all these profiles on Simplifier. We don't use FHIR IGs yet. So here you can see our FHIR profile of this zip, and you can see that we use this mappings feature of FHIR profiles to relate the concepts from the clinical information model, which are encoded using this string, which you can find, right here, to relate them to the relevant FHIR elements. So, and if you look at, for example, this problem name, you see that it is, well, it is this 513 code. So that's mapped in the profile to condition code. Well, it's for who knows FHIR, this is quite obvious. But and if you look at this, how we profile this element, you can see that there's a binding, a required binding to this value set. And if you click on this value set, you see that it is actually a value set which includes a lot of other value sets, including these, well, actually all these these value sets from the zip. I also showed you we have this verification status code list. This is a bit problematic if you go to FHIR, because FHIR, there we go, has actually a required binding on its own list, which is not SNOMED, but an HL7 code list. So what we do here is we use a concept map, which we which we bind to the profile as well, so you can find it there, and then you can see how the SNOMED codes, which are defined in the zip, how they map to the codes in the FHIR value set, the FHIR native value set. Well, 4 of these elements are luckily they are equal, but unfortunately the unknown status, that's problematic. I think that is I wanted to to show you an example of a minimum value set, but I couldn't find it in time, so I think I'll leave it at this. There.
I know, it doesn't like going back to sharing again. Here we go. Okay, thank you very much.
Thank you. Hello, everybody. I'm really happy to have this opportunity to present our work in Sweden, how we are working. My name is Mariam Razavi, and I'm representing the Swedish National Health and Welfare, which is also the National Release Center for SNOMED in Sweden. Brief introduction, very shortly, how we are working with implementation of SNOMED and also standards like openEHR and FHIR in Sweden. Quite similar to like Netherlands, we have also our national information references to make sure that everybody understand the clinical information consistently and also in the same way. So what we are doing, we are defining like identify the legal requirements. So our national references based on have like limited scope to the healthcare and social care. So there we are defining the legal requirements and what should be documented for the patient in the EHR systems. And then we are defining the conceptual models. What is the relationship between different concepts? And then we are defining the information models. There we are like giving the information about how they can think about the structuring the information in different systems. And then we are providing the terminology binding based on the use cases. It can be SNOMED, it can be like ICD-10 or ATC. Here I have like example which we implemented nationally in Sweden, and this is alert information, which is like as the name is like obvious, is alert information which some kind of information really specific and important for healthcare providers or workers where it can really affect the patient safety or the care plan. So this type of information should be visible on the EHR system for nurses or doctors in the EHR. So some examples can be like the infection risk or fall risk. So for this specific alert information system, we have like the national references, which all these 4 parts are defined, like the legal requirement, what kind of information have to be documented for the patient, the conceptual model and the information model, and then the terminology binding has been defined. So in this case, we have used the SNOMED in some parts. And then what kind of standards should be used is depend on the users, what they have in their real systems. If they have like open-air design, of course they can implement it. And that's the benefit of the national resources. It's not dependent on a specific standard. We are not locking like people in specific solutions. They can decide for their use cases. In some EHR systems, we have open-air implementation. They of course, as we presented this today earlier, they use like entry archetypes for alert informations and also SNOMED and local code sets. In other systems, they use like they have FHIR implementation, which in different parts, they use like different resources and also SNOMED codes to do the terminology binding. In the perfect world, when we are talking and presenting like the ideas, we are always talking about the terminology server, and some countries are really advanced in the implementation. Some other countries like us, like in the beginning, we have like many challenges, and we are not like in the advanced maturity level for implementation of a SNOMED. That means we are not using the terminology servers in majority of the systems. So some challenges appear in this work, then we need to figure that how to use the SNOMED in the real world with the FHIR or open-air implementations. So some solutions that we are using today is like we at the national NRC, we defined a ref set in the form of RF2 file in our extension release. So to make it easier for users to define the value set in a specific parts of this alert information. For example, if the patient has like a value set specifically to a specific part or attributes. And then this value set can be used like a static list imported to the EHR system. And then if there is a possibility to store the concept IDs and display term in the system. Otherwise, there's other approach can be like we are mapping the local terms to the SNOMED codes, and from that way we can use the SNOMED codes in our solutions. That is very short and concise, like about our implementation. Thank you.
Thank you so much. Good. Can I invite you up to give a brief overview around what's happening in Estonia and maybe the broader EHDS as well?
Hello, I'm Ruth from TEHIK, Estonian eHealth Agency, and also Estonian NRC for SNOMED. I don't have slides because I misunderstood the format of the discussion. But I think like the main points have already been covered sufficiently. So maybe I just bring out some of the differences or some of the things that we do our way. So we also have logical models, which are supposed to be independent from the technical implementation, because we have been using CDA and V3 for a while. Now we're switching to FHIR, and we expect the logical models to apply more or less to both, but more to the new thing, to the future services. We don't define any value sets in the logical models. And that's partly because our terminology authoring process is separate from the technical implementation or the technical data exchange specifications. So the logical model is really just a model. And then in the FHIR implementation guide or CDA specification, we define the bindings to actual value sets. Again, the value sets are not within the specification. It's not in the FHIR implementation guide. The value sets are maintained in an authoring tool and published in a FHIR Terminology server. So the links go all into the terminology server, and this is how it's used. And this allows us to actually update value sets very quickly when we have a new need. Then it's a matter of like, we can do it in the same day, and all our partners know that they have to update the value sets. So this is pretty much it for Estonia. Thank you.
And I thought while we've been having case studies from the national level around what we're doing within our implementations, I thought it might be useful to close this session out with an industry partner and Dougal around, well, he's a recipient, he works for a vendor company, they get these value sets. What does it actually mean and what's the value? So Dougal, can I invite you up?
Thanks very much. I don't pretend to speak for all vendors, by the way, but I think the patterns and the constraints that we all work under probably influence our behaviour. And I would say most vendors are good intentioned, but I guess the practicalities of implementation, we have constraints and things that drive us to behave in certain ways. So I tried to play a little game of top trumps with different types of bindings and how it appears to us in industry trying to implement things. So you'll see that we've got like no binding, we've got abstract binding, and I've got contextual binding. So abstract binding is kind of like where you've defined some loose rules, but you haven't really told somebody what to do. Whereas contextual binding would be where you've been very clear, you've been very specific about, you know, this field must come from one of these specific things, and all of those fields would be valuable. And you can kind of see that, you know, from a contextual binding is very expensive from a specification point of view. Like it takes a lot of effort to get right, but it kind of has that upfront effort makes it so that when it comes to a vendor to implement it, it becomes the easy answer to implement something is the right answer. So you're turning, you know, we're pretty simple, right? We have kind of three things that constrain us, and you probably have similar things. It's like one is money. Like money always matters. So if it costs more, the cheaper option gets done. We have time constraints. So we're right. We don't have flexible implementation things. We have deadlines that have to be met, that have, you know, contractual penalties, and we have you know, the unicorn problem, which is what skills you need to do to achieve something. And so things that have, you know, low implementation effort, low TCO, and low unicorn ratings are very attractive to a vendor to implement, right? You'll see, you know, the upfront effort of implementation, you know, is quite high when you don't give somebody enough information to work out what you're really trying to do, what you're really trying to collect. You know, the thing that in the long term, if you're implementing a system, if somebody can say, I'll give you something and I'll also maintain it for you, it takes a whole bunch of pain away and also drives up the quality of something, because it means if you change your mind on something, you can easily change it centrally and then propagate it out. And terminology services are kind of a way of implementing a feedback loop where change actually happens, like positive reinforcement change happens because everybody's working off the same thing. Somebody spots something wrong, somebody fixes it, they fix it for everybody and everybody benefits. And these kind of unicorns that everybody has trying to make all this kind of work, effectively, if you need less unicorns to solve the problem, if everybody kind of shares that effort up front. And a lot of this is to do with, you know, the bindings to collect data in the first place. But I just thought I'd kind of finish with the data value aspect of these bindings, because the context of a binding when you're collecting information helps you to collect it well, but it's also relevant when somebody's interpreting the data later in the cycle, because different context has different meaning. And if you're trying to do research, you're trying to do comparisons, then you know you can end up in a situation where you know what the question was and you know what the answer given was, but the answer doesn't necessarily mean what you think it means, because the answer is influenced by what answers were made available to somebody to respond to the question.
We will jump back to the Mentee, if I can figure out which one I put it in here. Awesome. Okay, if there's anyone else who's got questions, I know there are 4 in here already. We'll go. Figure out which one. Okay. First question, who would like to answer this question? So what's the official stand about representing negative SNOMED concepts? Example, does not have type of findings.
I don't know if someone posted this to press my buttons. So I think the official stand is that it's mixed. You'll find different approaches to this in different IGs. And you'll also see an evolution over this of what people do across a single IG. And if you look at the IPS IG, for example, there's you know, no medications, right? No known medications. And there's been a shift in how this is represented. My personal opinion, negation does not live in the terminology, it lives in the information model. And one of the reasons that you want to put negation in the information model is that you can reason with it there, and if you try and reason with it in the terminology, it doesn't work. And the IPS is actually a really good example of where this has gone wrong. If you look at the value set binding, or the definition of the value set that's bound to medication.code, it's got descendants of medicinal product, that's all good. Exclude vaccine products, okay, so we don't want vaccines in there, they're out of scope. Or no known medications. Or actually it says, or all descendants of no known medications. And there's this hedge there. There are no descendants of it, by the way, but there's a hedge there, and someone might want to say there are no beta blockers, right? Person's not taking any beta blockers, so something slightly more specific. But subsumption doesn't work that way for negation. So no, not taking any beta blockers doesn't imply no known medications. No known medications implies no beta blockers. The subsumption works the other way around. So that counterintuitive way that inherent subsumption and inheritance works, it's not catered for properly in SNOMED, and it's very easy to shoot yourself in the foot. And so that's why you want to put the negation in the information model. Does FHIR consistently provide the right levers to do that? No. So I talked before about context and the way the context of other fields might affect the interpretation of your terminology code. One of the challenges is that in the definition of those resources, those interactions are not explicitly called out. So it's not clear when you have, for example, a status field, which bits of that resource the status refers to. Does it just refer to the condition that you're recording, or does it refer to other parts of the resource? That's not explicit. So these are all the difficult and problematic bits that exist and we have to grapple with.
From an open-air point of view, we agree. And for a long time, we've had some specific archetypes. We model from the point of a positive statement always. So we actually have an archetype that's about absence of information. So we're recording that something is absolutely absent. So if you imagine you have a new patient coming in to see you on your system and you've never seen them before, so every single list, your allergy list, your family history list, should have absence of information so that we know that we explicitly have not asked. We don't know what the answer is, but there is nothing for us to actually be able to make decisions on, and especially if we're going to exchange it, we want to be overtly saying that there is nothing here. Then when you ask the patient, do you have any allergies? They can say no, in which case we would have a positive statement of exclusion. There are no known allergies, then becomes put into that list, same with problem diagnosis, same with medications, family history, etc. And then when they do have an allergy that occurs for the first time, you were able to actually record that as a positive statement of an allergy that's actually happened and the reaction information. And those are all mutually exclusive within any of these lists to make sure that when you do extract it and when you do exchange it, then you actually have a positive statement that is always giving you appropriate information for the purpose. We don't just leave a list sort of empty and we don't know exactly what's going on.
The next question is, I know a little about FHIR. Can you maybe explain a bit how the interoperability part works in practice? So if I'm exchanging allergens from one EHR to another EHR.
Okay, so this is a good one. There are different approaches. So the simple, not really, the simple localized interoperability approach might be for the two groups who are wanting to exchange that information between the EHRs to get together and define a FHIR profile that says, here's how we're going to represent, here's how I'm going to represent what I've got to send to you so that you understand it, and vice versa, and we come up with a shared way of representing what we each have for exchange. And then you've got interoperability between those two EHRs. But you wouldn't really do that in a vacuum. You do that in an ecosystem, and that ecosystem might be one where you have a national level or a EU level or a state level implementation guide that overlaps with this space. And so you'd use that as your starting point. And so you would converge that way. And you might look to other IGs that already exist. You might look at IPS or other IGs that have already tackled some of these challenges and use that as your starting point, or even as your ending point. That they may be there already and sufficient to do that.
To add on to that answer or further questions? Yes.
Sorry, if I may, it was for the previous question, but for allergies, especially in Belgium, what we have done for the negation is actually using the certainty degree. So everything is recorded as a positive statement, and then we use certified absent to certify that the allergy is not present, which gives you the ability to have very specified, say, he's not allergic to cat, and the day comes to become allergic to cat, it's just a change of status actually of an existing entry. So this is much more flexible than having outsider cause and then not being able to map between the no allergy and the actual allergy that has been apparent. So I find this is quite a nice way to do it for conditions also, certifying a procedure absent or condition absent, just using the certainty degree.
Yeah.
Thank you.
FHIR additional bindings, what's the state of tooling support? Or on the other hand, specification maturity level for these and how widely used by systems?
Short answer, I don't know. Slightly longer answer, I expect that there is existing support in the validator for some of this stuff. Although some of it you can't check, it's not relevant at a validation level. You know, the UI additional binding is not something that you would validate. There is work planned to do checking of the interaction between all the specified value sets in the different kinds of bindings, because, you know, if you've said, well, this is my extensible binding value set and here's my UI value set, and they don't overlap, then maybe you've got a problem. So looking at that sort of value set, intersectional value set overlap aspect is something that is planned work at the moment. The other thing is something that's a nice but under recognized feature of the terminology APIs is we generally talk about you use the expand operation and you point at the value set and you say expand that value set, and that's what you bind to your user interface element. But there's actually another parameter to expand called the context parameter. The context parameter, the value you pass, is actually the element in the profile. So the thing that actually has the bindings on it. And so then your terminology server says, oh, now I know the full context for expansion of this value set. I can see the binding, I can see the additional bindings, I can do smarter stuff. So an example of what you might do there, let's say we have a binding that is very broad. It's the base binding, and normally you would just expand that, but you have a UI binding that says, hey, these are the preferred things for the user interface. You might want to allow the search results, you might want to prefer the things that are in the UI binding to come back in the order of matching. But if there are no matches in that UI binding, provide additional matches that come from that broader value set. So you can do a more nuanced ranking of the search results and provide a better user experience. So you get the preferred things matching, but if there's nothing that matches, but something that's still in scope that does match, then you can get that. And there are terminology servers that support that parameter.
So final question on Menti, but please for others, please add them in. With regular new versions of FHIR, SNOMED and openEHR, how sustainable is the maintenance of mappings, binding and other cross-standard artifacts?
One of the things about the maturity model of FHIR, so I'll focus on the FHIR thing first, is that gives you a sense of how stable different parts of the FHIR spec are. The target for R6 is that it will all be normative, right? So we won't be done, but it will slow down tremendously at that point. The extension mechanism gives the ability to pre-adopt features and also extend things into the future. So there's the ability to work around things there. Most of the implementations these days are R4 based. Some countries, Estonia, are R5 today. I think it'll be a while, but R6 will gain adoption. Terminology, rapid releases. We release SNOMED in Australia monthly. The international release comes out monthly. There's no requirement to update your bindings as rapidly as the underlying terminology updates. So you can go at the pace that works for you. If you have rule-based value set definitions, they require less maintenance, not zero maintenance, but less maintenance than explicit identified concepts. But then things like SNOMED, and this is one of the really fabulous things that SNOMED has that many other code systems don't have, is the history reference sets, which give you replacement concepts. So that really helps you in that maintenance problem. Mappings, this is the reason you don't want mappings if you can avoid them. So map to migrate, not map to maintain, because mappings are a headache. The other thing is this issue of governance and who owns the value set, and so where the cost of this maintenance ends up landing.
Map to migrate, that's the theme. Map to migrate.
Yeah.
Let's busy with clapping.
Yeah, map to migrate. But yeah, so who owns the value set? They're the ones who are responsible for maintaining it. You don't really want to end up being the person in the middle that is responsible for maintaining all these value sets where you really don't understand the context of use and so forth. And I think that's interesting in the context of some of the work we heard about earlier, where the value sets are sitting outside the implementation guides, and whether that separation will cause some friction or challenges because the people who own the reason for the value set and not the people who are owning the maintenance of the value set. So that might be a challenge to look at.
Michael, if I could just add, sorry, I'm over here. Onto that, I think you touched on value set, rule-based value sets and maintenance issues. I think the other thing I would add to be careful with, and there isn't necessarily a right or wrong, it's what's right for the particular context, is the definition of those value sets in terms of the versioned or not versioned references to the code system or code systems that underpin that, and also very careful thought in the URIs for identifying the value sets and the versioning of the value sets themselves and how they're maintained over the time. You can make the problem much harder or easier for yourself, depending upon those levers as well.
Yeah. So one of the subtleties of defining a value set is when you say codes from this code system, you can specify the version of the code system at that point, in which case that's the version that's in use. You can sort of manipulate that from the outside and force it to be a different version in a context, but that's a special case. But you can also leave the version blank, and then that means the latest version available. And so you don't need to maintain the value set definition unless the latest version of the code system starts to include or skip codes. And one of the challenges there also is codes that go inactive in SNOMED lose all their relationships, so they often drop out of the matching rules. And if you've got a value set that's defined for interoperability and needs to deal with historical data, you need to keep those inactive codes in context. So you might need to use something like the history operator in your ECL to bring those codes back into scope or to manually add them in.
Fantastic, thank you. Just in the closing few minutes and before Alejandro comes up, really, oh, sorry, Gal.
I think it is important to remember also that it is, of course, easy to see the problems and handle the problems when they come. But I mean, at least both SNOMED CT and openEHR are quite slowly changing. So just because there is a new monthly version of SNOMED CT, everything hasn't changed. In fact, it is usually quite small changes and usually just additions, and they are fairly easy to manage. So yeah, we shouldn't overestimate this problem.
Well, thank you. We'd love to know your takeaways from this session. Was this useful? I know that the SNOMED International team are probably interested to know if these are similar kind of things that we should do in the future, these kinds of education sessions. So please, while Alejandro is getting ready to come up and show some of the awesome work that the implementations team has been doing, are there any key takeaways? Have you learnt stuff? Do you want more like this? We'll just give that a couple of minutes to pop up. The QR code is there, so please use the QR code. We will definitely make the slides available. So for those that use their own, looking at you, Michael, use your own Mac to present. Yeah, we'll compile it as a slide deck and provide that to SNOMED International to make them available. Oh, and my screen. Oh, loving doing this. I'll just read them out. So while you connect up and get ready to go, we've had around, I really like the openEHR way of working, helpful presentations going from basics, good learning, good session and learning, so much more to learn and understand. SNOMED, FHIR and openEHR complement each other perfectly. Really loved hearing about the national use cases. That was really helpful. So thank you to all of those countries who presented. The Q&A session was fantastic. So very useful, please more of this. So thank you so much to the speakers and Alejandro, really looking forward to seeing the awesome work you guys have been doing.
Yeah, very quickly in 3 minutes. We want to show you the implementation support portal. If you go to implementation.snomed.org, if you go to showcase, you will see the demonstrators. It's a collection of different tools that show you how SNOMED is used. For example, Michael showed the clinical user interface demo in which you can create like an encounter record searching in SNOMED, or the context representation transformations, yes. You will find many of these. Many are based on FHIR resources, like the allergies one. Now that we have a collaboration agreement with openEHR, we'll be happy to also include openEHR transformations and examples here. This is how you can create like an allergy report. I think it's there. An allergy report using SNOMED and FHIR. So if you do allergy to aspirin, something like that, this represents the consensus of the clinical reference group about not only how the information is collected visually, but also the behavior, how you can automate some of the fields, what are the options. You can either record the propensity or the substance and things like that. And you see like the FHIR representation on the right. The other one that is related, that maybe it's interesting and is related to one of the questions, is the questionnaire manager application, which could be similar to a archetype manager application as well. This is connecting to a FHIR server that connects a collection of questionnaires that can be somehow aligned to archetypes. But this is focused more on how you maintain the terminology bindings. Yes, because each one of the questionnaires have references to fields they have reference to the meaning and to the fields. Yes, so if I go to the carcinoma of exocrine pancreas form, for example, we can see a preview. You can fill all this information in the form. I have concepts on the left for the name of the fields, and you have concepts on the right. Every time you select an option, one of these options, there's a clinical SNOMED concept on the background of that. And they're authored with the NLM authoring tool that Michael showed. But you can click on this button, and this will extract all the references to SNOMED concepts on the forms, yes? And when you click validate, it will go to a terminology server and check if each one of the concepts referenced in the questionnaire are still active or if have changed. Some of the concepts are specifically referred to, like operative procedure. This is a minimum basis of the operative procedure. But then for the operative procedure options, you have all these, and you have an option here. And some of them are part of the query, not of the result of the query. If you say, give me all the kinds of procedures, only the concept procedure is the one that you are referring on the query that you need to update if it was inactivated. Like Michael was describing, and Dion, if you have a dynamic field where you say every kind of procedure, if the procedures change in the SNOMED, the query is still valid, so you can still run it, except one of the concepts mentioned in the query changes. And when something changes like this, it's a bit small, but in green you can see how you get the concept is inactive and it can be replaced by this other concept because SNOMED contains the history tracking mechanism to facilitate these replacements. So yeah, we envision that probably if you have a collection of archetypes that also have references to the terminology, you need some kind of tooling like this to maintain all the references up to date every time the terminology changes, for example. And all this is open source and is as an example, so implementers can use tools like this and implement similar things on the local systems. So thank you very much.
It's happening after lunch for those that are continuing on.
Sure, thank you, Kate. So this afternoon, we'll dive into the use cases in Belgium and in the Netherlands for using a FHIR terminology server as a national terminology server. And we'll share also some experiences from that we already have with the product onto server from procurement to initial implementation. So first, there will be an explanation of the roadmap, the plans, so the what and the why. And after the break, there will be some demos, and we will dive deeper into the how. So if you want to learn our experience with the onto server product, you're all very welcome to join. Thank you.
Thank you for your questions, and please enjoy lunch.